Welcome back to Programming Fundamentals. This is going to be video 5 of my little Programming Fundamentals series. I'm glad you've made it this far. Congratulations. You are a programming god at this point. Well, okay, maybe not yet, but you're not. Well, okay, you got a little while to go. But if you stick with me, you're gonna be alright. You're gonna make it. You're gonna know how to code some stuff. You're gonna be able to think, program, and yeah, and do other stuff. I guess. I don't know. Whatever. I'm trying to be cool, but it's still not working. I don't know. Maybe I should just stop on that. Anywho, I just pulled up NetBeans. I wanted to show what it looked like whenever you just pulled it up after you've closed it out, just so you know that first Java, the first one that I made, is still pulled up over here. All you need to do is click on the first. It's inside of this what looks like a little package. Oddly enough, it's called a package, and because it looks like one, and it is one, and yeah. Excuse me. Then you'll click on the source file in this package called firstjava.java. Double click it. It comes up. Ooh, what do you know? Get rid of that start page. That's all that is. And I'm going to go ahead and do an Alt and mouse wheel up to zoom her in. Isn't that better? You can see. Nice. Okay. The topic for today, I believe I'm going to do variables. Variables. That is what computer science is all about. Variables. That's a lot of what a computer science really is. It's just variables. We're dealing with things as they change. If they were the same all the time and we couldn't deal with variables, it would be pointless to really even have a program to begin with, because there would be no sense of dynamic change, I guess. I don't know if that's proper, but whatever. Who cares? Anywho, so we'll get started here with a variable. Now we're going to create a variable of a specific type. Now you remember that last video we talked about integers? Well, we're going to create a variable that is going to be an integer. So we'll call it, oddly enough, it starts with integer. And then we're going to give it a name. Ooh, I don't know, let's call it number. And we'll do just that. Now what this does is declares an integer called number. It has a name so we can refer to it. What this does is this sets aside memory for us in the RAM when the program actually executes, so we can have some sense of storage. And with the storage, we can actually go back and go to this variable and actually make changes to this number, if you will. Now, I didn't set it equal to anything, which is why it just looks like this. So this is just space with nothing in it. Well, it doesn't technically have nothing in it, but we'll just say nothing for, I don't know. I don't feel like getting into the hardware details. Just read about that. Anywho, so here we have an integer called number. Now this is declaring it. Let's initialize it. Let's set it equal to 5. So looky there. You've created an integer called number, and you set it equal to 5. Congratulations. You're really starting to do some cool stuff. I mean, here soon you'll be able to make the next, you'll be able to make another zombie game, So congratulations, because that's what we need, is another zombie game. Anywho, I need to stop saying anywho. I don't really like that word. I never say that when I'm talking to people in real life. I don't understand why I'm saying it right now. But I don't know. Whatever. Okay, so we've talked about a variable and this type called integer. Because in Java, when you have a variable that you need to define what it's going to be. And we know what integers are. We talked about those in the last video. And we created a variable that holds an integer. Now let's get into what we can do with it. Now you remember before how the system.out.println, our favorite method, can accept those text or strings, and we can type in, like, say 5 and have that print to the console. Well, guess what? You can pass a variable of the type that it accepts. This is actually referred to as a string literal because it's just literally a string. Really, there's actually string variables as well, and those can be passed. Same works for an integer. You could just type in an integer, or you can type in something that represents an integer, like some stored portion of memory, like we have here, known as number. And check this out. What do you guess is going to happen? You ready? Oh my god. It didn't print out number. No, it printed out what number is equal to. So that is pretty important. Now, I am using an integer number instead of equal to 5. Integer does have a limit, so be careful. The limits, I do believe, can vary between, I'm not sure if it's all the same. In Java, it's probably the same, because that's what makes Java Java, is its portability. But I believe, correct me if I'm wrong, I think it's 2 to the, it can allow up to 2 to the 31st different numbers, but the highest number is 2 to the 31st minus 1 if we're allowing for unsigned, positive numbers that is, and signed, negative numbers. So it kind of goes back and forth. That's a little bit computer sciencey. Just know that if you're going to deal with numbers that are, over 5 billion, you want to start worrying about, what's called integer overflow. And I'll actually show, well, I don't know if I'll show you, but really what happens is, in computer science, there's these things called, this thing called binary, which is the number system, which is the representation of the on and off, signal. So, binary, I don't know if I should go, how far I should go into that. Anywho, every single place is, it's a 2's power. And if there's 32 bits, you can have 2 to the 32 different numbers. But you have to have a placeholder that contains the sign number. So this would be, which is why it's 2 to the 31st. I do recommend looking up some binary stuff. If others or anyone really has interest in that, I can go over that a little bit more. And I know I didn't explain that all that well, and it might have been kind of wrong too. But just understand that you can't just put, infinity in here. There's limitations on that, both on the positive side and I believe the negative side too. I don't know what to think about that. I don't know. Maybe I should have went over that before I, made a video on it, representing my knowledge of it. I don't know. That wasn't the point. The point of this video is to go over variables, and that stuff is important. Just, if you start to deal with larger numbers, you're going to want to think about, the various sizes, and, maybe do a little bit of researching. That stuff could change too, so it's better to know about it than know exactly, what number, is this number exactly too big? Again, that's dealing with a little bit of a memorizing type of thing, and I don't really believe in memorization all that much. But yeah, we have a variable, and you can also apply math in the variable, like do 5 plus 2, which I think we went over before. That was 7, right? Yeah, it's still 7. Interesting. I don't know. Mind-blowing, if you will. Okay, we went over it. Now, there are other types of data that we can have for variables. We mentioned before those floating point numbers. Now, remember, integers can only contain integers, meaning if you try to enter a decimal, like 5.0 or 5.2, you're going to get a syntax error because that's not what integers are designed for. They're designed for integers. But let's say you did need to store like 5.2. Well, you could do float, number, call number 2, equal to 2.5. Oh, wait a minute. This isn't working. Well, doesn't this qualify as a working value? It does. You have to add in something a little extra. An F. Yep, and that's not for fuck. That's for float, just so you know. Excuse my French. 2.5F. That's how you deal with floating point numbers. Now, there's some things I should mention. You can name your variables pretty much anything. You can just kind of play around with it if you want to see something works. The naming convention that I usually use is something called camel case, and it's where you start with the lowercase, and then every new word after that would be a capital letter. You can't put spaces between your variables because that constitutes as white space, and even though white space doesn't typically matter, it does matter for like declaring stuff because you have to be able to, separate words like integer and float. Because if you do like this, that just doesn't work. But camel case, give me an example. If I were to do like penis size, that's camel case. And for most people, actually no, not for most people. I would say most people it's an integer, but no, really. I would say that for me, like 4.5 or something. No, I'm probably around like that or something like that. Oh look, I'm using it. See, I messed up. I'm trying to put a float in an integer. You can't do that. You have to do it like this, and that works. Now also, you can print this off too if you want it to see that. Oh no, can I not do that? Oh well. Why did I name it? Well, I don't know. I'm tired. Give me a break. But 5.5. So that's that. So we talked about integer variables, floating variables. I know I'm going a little bit over on time, and I apologize. Integer, float. There's another one that actually it's a little bit more, is double point floating precision, and it's just double. So if you need more precision, you can do the same thing. It takes up more memory to use double, but sometimes you are forced to use that. But that is available to you. It's the same. It works a lot like float. It just gives you more precision. I don't believe you actually require the F for double though. So if you were to do like double, my friend Andrew's penis size equal to 10 F. Do you need the F? Oh, you don't. So that works too. So yeah. And so we've talked about integers, floats, double. Let's talk about char, or characters. This is a variable that holds a single character. You remember that text that I kept showing you earlier with the hello world and all that? Well, you can store that into a variable, except characters only allow you to store one character, and you have to use single quotations. This. And we'll put these more into practice later on. I would definitely, read more about these if you really want to, but the ones that we'll be using, you'll obviously see, so I'm not gonna hammer you to death with the little details of each variable. Just know that variables vary. You can change them, and we'll in the next video I'll actually go a little bit more detail with changing variables, just to make sure you understand the execution flow of how it all works. And yeah, and then we'll get into some interesting stuff, and things are picking up a little bit. We can do variables now, and I can show you, and you've seen now how variables just represent something in memory. So if this method right here accepts that what's called data type, these are all data types, then it'll still print it out as if you just typed it in. Literally. That's how variables work. You treat them as just if you're typing them, just literally. So yeah. So that's that. Have a good day.